Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. We are here today with a special project using Raspberry Pi Pico microcontroller and MicroPython to build a simple four-wheel drive robot. Alright guys, in the last couple of lessons, around 10-12 lessons, I showed you from the basics, from the scratch, how to install the IDE, how to configure your Raspberry Pico microcontroller, and then I showed you how to connect multiple sensors, start reading the information from the sensor, and start playing around with the codes and stuff like that. But now we will use all those previous lessons, including driving two DC motors and a servo motor and ultrasonic sensor. We will start building a small mini robot. Okay, so basically this robot is nothing but people who are from Arduino world, you would have built ton loads of obstacle avoidance robot. It's on the similar concept using Pico but with MicroPython code. Okay, so this robot basically it's going to be, it's not an easy lesson though, but if you follow along, we can make it, we can build it together. So we will use four different motors, four wheels of course, and a motor driver and Raspberry Pi Pico and couple of other electronics to build along. So it's going to be two different deck actually. We will first build a very basic robot which can just move forward, detect an obstacle. If there is an obstacle in the front, it's going to take a left or a right. In the right, if there is an obstacle, it's going to turn back, again take a left. And if there is an obstacle in the left, it's going to turn back and move forward and move reverse. All those logics we will write using MicroPython code. But the most interesting aspect is as we go along, above on top of the same board, I am going to show you how to fix a Jetson Nano single board computer, and then we will connect Raspberry Pi Pico to the Jetson and we will add a LiDAR, which is light detection and ranging, and also we will add a couple of more advanced modules on top of that to make this robot as a fully functional autonomous driving robot. We will also build ROS, robot operating system. We will install ROS, probably ROS 2, that will be a better bet on Jetson Nano, and I will show you all those magics how to build it. It's going to be pretty small. Let me show you some of the components which you may need to start collecting before we start building the robot. All right, so in this lesson I will show you each and every components we will need, and we will also get along with the configurations and stuff like that. So let me just switch over my other videos. So here if you see, I have two acrylic plates. It's made of a pretty thick acrylic. So you get this ready made in the market anywhere in Amazon, or or maybe you can just, I will drop in the 3D print design. You can get it 3D printed. So you need two of these guys. One is, both are same, but except that one will have another hole to mount your servo motor, basically for ultrasonic sensor. So go ahead and get this printed, and you will need a L298D, a driver, a motor driver. Basically we will be using ROS serial through Jetson Nano in the future lessons when we build a double deck. For the beginning, for the basic robot, we will just use one single deck. Okay, one single deck, and there are multiple holes here. Can you see that there are multiple holes? So in future when we are adding Jetson Nano, we will add another plate on top of this. Let me just lift the camera a little bit so that you guys can see much better. So I'm going to add one above the other to mount Jetson Nano on top of this to make it fully autonomous. But to begin with, we will be using just one single deck. Okay, one single deck, and that's going to be the basic robot. And we will need four different BO motors, just ordinary 150 rupees business the BO motors, which is available anywhere in Amazon or any other online platform. And we will need about four small wheels. Just this is just about 50 rupees, these wheels. You can go ahead and buy it. And most important thing, for powering the robot we need this rechargeable battery 8650 at least 3 batteries you need, because we need minimum of probably 12 volt, but 11 and a half volt should be fine. Make sure that when you buy this battery, you go for 2000 milliampere, okay, the current, so that will sustain for a longer period. And then of course you will need a ultrasonic sensor, which we, in one of the previous lessons, we built a project on that. So go ahead and procure the ultrasonic sensor, and then a mounting port. So this is again a 3D printed or even a plastic ready-made stuff which is available in the market, which is just about 50 rupees. So go ahead and take it up and get one of this small servo motor, okay, SG90S, it's MG8090S, this kind of servo motor. And of course the microcontroller Raspberry Pi Pico, we will need one of this for now, okay, and two small size breadboards. We are not going to do any soldering work at all, so go ahead and procure this kind of breadboard. So this is going to be, again, just about 20-30 rupees. You can get this board, and there are bunch of wires, like these kind of jumper wires. You may want to pick up some of the jumper wires and stuff, but the motor wires has to be differently soldered. So you may need a soldering iron to solder the wires and keep it ready. 4 motors, we need 4 of these, okay. And what else? I think that's pretty much, guys. So it's going to get interesting. This project is all about making a very simple robot detect obstacles and then make it to work through few Python, MicroPython code scripts. And then at a later stage, we will add Jetson Nano single board computer on top of that and start doing some artificial intelligence and install ROS2, Robot Operating System 2. And I will show you how to build an autonomous robot using a LiDAR, and also we may need a camera in future. So I will that's going to be part 2 of this series. Alright guys, this was just an introduction, so go ahead and procure these materials, keep it ready. We will start building in the next lesson. Bye bye.